This workshop today is a part of a bigger thing, a course that we call Machine Learning Zoomcamp. This is a course about learning machine learning engineering. We created this course, and I am the main instructor there. I think right now we don't really have any other instructors in these modules. So I'm the instructor for this course. This course was created quite some time ago. It was created around 5 years ago, and it's based. So this is the link. Actually, let me show you how you can find the link. So this is the YouTube video you're watching. You can just click here in the description, and then you see the course here, right? So you click here, you go to the website, and this is the course. It's called Machine Learning Zoomcamp. So this is the link. So I created this course quite some time ago, and the course focuses first on some machine learning basics, like what is regression, what is classification, how to evaluate the models. And then at some point, specifically in module number 5, we start going deeper into machine learning engineering topics. In particular, once we create a model, we want to deploy this model. We want this model to be useful for others. And this is what the module number 5 is about. And as I said, this content has been created some time ago. So this course has been created around 5 years ago. And the course is based on a book I wrote. And the book was created a few years even before the course. So with time, new things appear. The concepts are still the same, but there are new libraries that work better, that work faster, that are more common. So the purpose of today's workshop is to give some sort of module update, give new information about the way things are currently done. This is not significantly different from what we did in the module, but some tools are no longer used. There are other tools, or not no longer used, but less used than before. So I want to give an updated version of this module. That said, there is a lot of theory in this module. I will not cover the theory. So this theory, you can go and check it yourself. Like, for example, when we talk about web services. Here, I will not talk about this a lot. Like, what's the purpose? Why do we need web services? It's all explained in the course. So you can watch the videos in the course. And if you want to learn more, if you want to learn some theory behind what I'm showing today. So today we focus mostly on the code. So I will, of course, explain some of the things. I'm also taking a look at the live chat. If you have some questions, I will be happy to answer these questions. But the main purpose of today's workshop is to update the module and use newer tools. In particular, here we use tools like Flask for creating a web service. It's still used, it's still quite common. It's a very simple application, but FastAPI is another Python library for creating web services. Web applications has become more popular since the time I created this content. So I want to use that in this workshop instead of using Flask. Then pipenv, the tool for managing dependencies, for creating virtual environments. It's a very nice tool. I really like it, but it's quite slow. And there are a newer, faster alternative called UV. This is exactly what we're going to use today in order to manage dependencies. For some things, again, like what exactly is a web service, what exactly is virtual environment, please refer to the course. Here, I'll just describe it briefly. Then we will use Docker also for containerizing our application. And when it comes to Docker, because we use other libraries, we'll need to update the Docker image we create. Again, for theory, please refer to the module. Here we'll create an updated Dockerfile with all the new libraries. And at the end, I will also show a different alternative way of deploying the model to the cloud, to the internet, instead of using AWS EB, which is Elastic Beanstalk. We will use fly.io. So that's the plan for today. And I'm a little sick, so I have a sore throat, so I might speak a bit less loud. Might need a break during the session, but I have tea. So I think it should work out. So let's start. And we will start by first configuring the environment. In the course, actually, I show you how to do this. So if you go to the course, if you go to the intro and module number 8, this is where I show how to configure the environment. But I'll quickly do it here so you can follow along what I'm doing. Another thing you will need is this link, workshop link. So if you click on this, go to the website. So this is the material for today's workshop. You see, I committed it fairly recently. So you can just follow along because maybe I go over some things fast. So you can just copy paste things from here and follow along. Okay. So that's the plan. I explained what this workshop is. I talked about the course. I also talked about this page. Just a second. So this is what we're going to use. Okay. So let's see. I wanted to start with creating a code space. Not sure if it was a good idea to actually do this workshop today. Yeah, I just didn't want to cancel it because so many people registered. Anyways, so I want to start with creating the environment for this workshop. For that, I just have a repository. It's empty. There is nothing. And then I click on this code button. You have local on code spaces. You select code spaces and create code space on main. What will happen is we will create a computer in the just a second. So what happened is we created a computer remotely on GitHub Codespaces, and it right now works here in the browser. We have actually many things here. So for example, I have Docker here. We have Python of version 3.12.1. So it has almost everything we need. For me personally, using it from the browser is not very convenient. I have Visual Studio Code, so I want to use it for interacting with this environment. So if you don't have Visual Studio Code Desktop, you can install it or simply continue using it from the browser. So I'm going to open Visual Studio Code. Okay, so it's loading. Yeah, I don't know why it takes time. Yeah, it usually does. Yeah, it's opening now. I also have Copilot enabled. So this is an AI assistant from GitHub. It will also help me. I will use it, but you don't have to use it. It's not strictly required for this workshop. So it's empty. I don't have anything in this folder. So this is just an empty repository. And I want to install, the first thing we will need is Jupyter Notebook. So I will do pip install Jupyter. And by the way, you don't need to use Codespaces if you have local environment with Jupyter, with Python, with Docker. You can just use it. You don't need to use that. Okay, and now I do Jupyter. Okay, so one thing we need to do is where is the workshop instructions? So I'm going to close that. I'm going to close this. So this is our workshop, and there is a starter code that I want to follow. So this is the URL to this starter code. It's also in this repository. So this is starter notebook. I want to download this notebook. It already has a model that we are going to train. So to save some time, I'm just going to execute the cells in this notebook. So we get a model, and then we will deploy this model. So to download this thing, I'm going to just copy this command, put it here, and now I have this notebook. So I saved it as, so this is the command, download the starter notebook and save it as workshop UV FastAPI. Okay, so now I want to start Jupyter. Actually, we want to install some other things. Pip install, I want to install scikit-learn. Do I actually have this in the instructions? I think I didn't include this, so I'll need to update it, but let me just type it. Pip install scikit-learn. What else do we need? Yeah, that's pretty much it. So that's, do we also need pandas? I think so. Let me check. Where's our starter code? So we will need pandas and numpy. Pandas, numpy. Okay, so it was fast. Now I finally can execute Jupyter. Jupyter Notebook. Right now what happened is we executed this and Visual Studio Code detected that there is something running on port 8888 and it did an automatic port forwarding. It means that this thing is running remotely, but I can use my local computer, my browser. I can just go here and type localhost and it will open Jupyter that is running somewhere else. So we have this Jupyter. In order to open it, I need to use this thing. Okay, now we should have Jupyter. Again, if you use local environment, it's fine. You just run Jupyter. Right? If you run this from the browser, you might need to go to this ports tab, add port, so it might not detect this, and the URL, it will be not localhost, but some other URL. But if you use the browser, then yeah, it should work. And there is a question, wait, I thought we were going to use UV. UV we will use later. So right now we just use Python, we just use pipe. Well, what did I do? We just use pip to install things globally. So they are installed. All projects have access to these things that we installed here. But later we will use UV for isolating it from the rest of the apps. So good point, but it will come later. Okay, so things are running. I'm going to open it right now. I have so many tabs open. Okay, so and what I'll do right now is just I'll execute this line by line. So the imports, again, I'm not going to spend too much time explaining what's happening here. If you want to learn more, this is actually taken from our ML Zoomcamp course. So this in module number 3, we learned about logistic regression. This is example from this module number 3. And here we just train the model in the same way as we do in module number 3, and we want to deploy it as a web service. Okay, so did I execute this already? Okay, let me just briefly explain what's happening. So we use, first we use pandas to get the data. This is how the data looks like. So this, the problem we're going to solve is predicting churn. So we have some data from an internet provider. We have some information about the customers, like what's their gender, if they're senior citizens, do they live with partners, and so on. We have a lot of information like that. We also know like how many they pay per month, how much they pay in total, have paid in total. And at the end, we see if they churned, meaning they stopped using this internet provider or they continued using it. And the way we can use this is imagine that we are working at this internet company, and we want to detect people who are about to churn before they actually cancel the contract. And we want to offer them some promotions, right? We want to say, hey, stay with us, we will give you 10% discount, for example, right? So this is the use case. And here we're doing some pre-processing. In the course, I explain what exactly we're doing here. It's not really important right now. What important is that this is the model. This is a classification model that, given a customer profile, will output the probability of this customer churning. Right, and then what we do next is we have some numerical features, tenure, monthly charges, total charges, and some categorical features. So whether they have phone service, whether they live with dependents, children, partner, like how husband, wife, and things like that, like what exactly, some description of the customer, right? And next we use a dictionary vectorizer. Dictionary vectorizer is a thing that takes our data frame. So this is the data frame, and it turns this data frame into something that looks like that. So let me show you first 3 records. So it turns the data frame into a list of dictionaries, and each dictionary is a description in this form of the customer, right? And then with dictionary vectorizer, we turn this this list of dictionaries into a matrix. So here, maybe to see this, I don't know. I think it's students. Yeah, so basically this is a matrix with our features. Here once mean the feature is enabled, or how to say that. Let's say if they live with dependents, then it's 1. If without, then it's 0. And we also have like monthly charges, total charges, and so on. Again, for more details, refer to the course. So this is called one-hot encoding, and we achieve this one-hot encoding with dictionary vectorizer. And then we have the model. So for the model, we use logistic regression, and we simply fit this matrix, and this is our features. Right, right now, I use the entire data set. In practice, of course, you need to split it into multiple parts, train your model, whatever. We'll all cover that in a different, in module number 3 and 4. So here, this is the model. So now we want to deploy this model. But how do we actually use this model? So let's see. Let's say this is the customer profile we want to, I don't know, let's say we want to evaluate all the customers we currently have, and we can come across this customer. So this is our customer. And let me change this customer a little, because I simply took this customer from our training data set. So in practice, you shouldn't just take data from your training data set. Let's say this is a male. They don't have a partner. They have a kid. What else? And for example, they spent 6 months with us, and this is how they pay per month, and this is how much they paid in total. Right, so this is our customer profile. Now we want to make a prediction for this customer. So first we use dictionary vectorizer to turn this customer into a matrix. So this is the matrix we're going to use for making predictions, because in the model you cannot put this information, you need to put numbers. And then you do predict probability for this, and in order to access the probability of churning, or probability, yeah, probability of churning would be this one actually. So this is the probability of churning. So the person with this profile has the probability of churning 54%. So if we are in the marketing department and we come across this customer, we may make a decision to offer, let's say, 10% promotion to these customers, so they don't churn, right? Churn. Okay. And in order to save this model, I just need a second. I'll be right back. Okay. I turn off my camera. So in order to use this model next, what we need to do is we need to save this. So for that, we are going to use pickle. So I'm going to import it. And okay, now we do, so we want to save it to a file. And the file, we can call it model.bin, right? So this is going to be our file with the model. So I will write with open bin. So this is the name of the file. And we want to write to this file, and the format is binary. And we call this, the handle to the file, we will call it foutput, right? And what we can do here is we can do pickle dump. Then what we want to save to this model.bin, we're going to save dictionary vectorizer and the model itself, and we're going to save it to this thing that we to this file, right? So now we can see that. Let me actually show more. So we can see that we have a new file. It's 2.5 kilobytes. And it contains dictionary vectorizer and the model. So this is how we save the model we just trained to a file. Right? And loading is similar. And by the way, if you're confused with this, so let's say you have no idea what's going on here, what you can do is use ChatGPT and say, explain this code. Right? And then it will say, so yeah, and then like if something doesn't make sense, then you can ask ChatGPT to clarify, to give you more information about that. Okay, so now this is how we save it, and this is how we load it. So for loading, we open it for reading. So here W means writing, RB means reading binary, and the syntax is load, and this is where the output of this function. Notice that we actually save two things. So we actually save a tuple that contains, so a tuple is like two things, that contains the dictionary vectorizer and the model, right? And then when we load it, this is the syntax, right? And then I want to use fin. So I always use fout and fin to make sure I don't accidentally overwrite something when I save it. So it's just a nice convention. So fout means file output because I want to write, and fin means file in because I want to read. Right, and this is how you read it. Right? So if I restart the kernel right now, so right now if I do dictionary vectorizer, it says, yeah, I don't know what it is. So now I can actually load this, and then dictionary vectorizer is back. The model is back because we just loaded it. And I want to, let me just put everything in one line so it's easier to copy paste it. So I want to execute this line, right? So now we can do a prediction. Okay, so this is the prediction, and we can say something like if churn is more than 50%, then we send email with promo. Else, don't do anything. So let's say this thing is running somewhere in the marketing department, and they apply this model for this particular customer, and they see the decision that of this model to send an email with this promotion, right? And of course, it's not a person who is doing this. It will be a web service, and we will come to this later, how to actually make it possible. Okay. So this is how we did it in the course, but there are some problems with that. So the one problem is we need to deal with this tuple. So we need to separately save it, separately load it, and when we train, it's also not convenient. Right. So first we need to do this, then this. What we can do instead is using a pipeline. So a pipeline allows us, instead of doing it separately like we do here, first we hit this, then we hit this, we can combine it into a pipeline, and then we invoke fit on the pipeline once, right? So it makes it easier, and we have just one object that we save. So I'll do from scikit-learn pipeline, import make pipeline, and then our pipeline will look like that. So first we have our dictionary vectorizer. So this is the first step. And second step is logistic regression. Dictionary vectorizer is not recognized. Okay, let me just re-execute all these things. Because remember, I restarted the kernel. Okay, so and right now, what we do is we don't need this xtrain anymore, because this feature matrix will be created internally in our pipeline. What we'll do instead is we will simply fit our pipeline on the dictionaries and on our target variable. Okay, and we have this pipeline, and you see we have this nice visualization. It says that, okay, there are two steps, first dictionary vectorizer and then logistic regression. And now we can save it. Instead of saving two things, we save only one thing. So let me move this import here. And now I think I will need to execute it. And so now I save it. I now can load it. And here, instead of doing two steps like we did here, I just do pipeline predict probability on the customer. So I pass the dictionary with the information about the customer directly here. So let us also print churn here, just to know what's happening, right? Prop of churning equals to this. Okay, so this is already quite good. So we made already an improvement over what we had previously in the module, and we have the pipeline that we saved. And what we want to do next is we want to, because doing this in a Python, in a Jupyter notebook is not convenient, because we don't want to open this notebook, execute all these steps in certain order. It's not convenient. So what we want to do is we want to turn this notebook into a Python script. For that, I will open the terminal. So Python notebook is still running here. I'll keep it running. I'll just open a new terminal, and I will execute this command, Jupyter NB convert. So I want to convert it to a Python script, to script, and then I'll need the name, right? And what happened nb convert. I missed t at the end. So now what happened is we have this file, yeah, what we will do now is we will edit this file, and I will call it train. But even if we don't edit, I think if I just go to the terminal and execute Python train, it should still work, right? So, but first of all, it does two things. So it does two things. First is training the model, and second is making the predictions. So I actually want to split it into two parts, train and predict. So for predict, I will take these last lines, right? So this is the only things we need for prediction. So now, right now, let's focus on training. So make it a little bigger. So I will now edit this. So I will move all the imports to the top. And I like the way I like doing this is first I have system imports, then libraries, and then named imports like that. Okay. Then here we have code for downloading the data. So what I'm going to do now is just create a function, load data. And inside this function, we will have this. So what it will do is it will load all the data and return the data frame. So there is some preprocessing happening, but then at the end, we'll have a data frame with all the preprocessing. The next step is we want to train the model, right? So this thing, let me put it to the top, to the other imports. Then I'll call it train model. And so it takes in the data frame. And then applies this training. We will also need this thing. Right. So we have the model. We have categorical numerical features. We have the pipeline. We have the dictionaries, the target variable, and we just need to return pipeline. And then, yeah, what else do we need? So first, let me just load the data. Load data. Then next pipeline is train model on this data. And the last thing we want to do is save model, right? And we want to save it to model.bin. So this is how our last function will look like. Def save model, file name, model. So we'll change it slightly. This is file name, and this is model. And let's add a print statement. Model saved to name. Okay, let me execute that. Okay, so now we have the script, so we don't need to actually execute to deal with this Jupyter Notebook. Now we have a script, and with this script, we can put this script anywhere we want. So we can put this in the cloud, in AWS, or whenever. And we also have some modularity here. So we decomposed it into load data, train data, and save model. So there are 3 steps. And if we wish, we can use some kind of orchestrator, like, I don't know, Airflow or Prefect or something like that, to actually execute this regularly. We will not do it here, but this would be the next step for actually making this train.py script production ready. But this is already good enough. We don't need to deal with Jupyter Notebooks anymore. So we have this train script, and now let's deal with the predict one. So here, do we need to import anything? Let's just try to run it. So we'll just try to do Python predict. Okay, yeah, we need to load pickle. Okay, so with predict, it's very simple. It's another script that loads the that loads the model and applies the model to this particular customer. Cool. So we have already done quite a lot. So we train our model. We then created a script. We split this. We converted the notebook into two scripts: a script for training, a script for predicting. Right. Let me just quickly check the notes of what we want to do next. Right. We also use pipelines, and now the way predict looks like. So we cannot expect our marketing department, like I don't know, somebody from the marketers, to manually go change this file, put the features in, execute the script, and see what is the prediction, right? So a different scenario is they actually there is a service, web service running on the marketing department side, and there is a service running in the, let's say, in the data science team. The data science team exposes this service. It says, okay, well, this service is running on this URL, and whenever the marketing team needs to get a prediction, it makes a request to this service, gets back the prediction, and then makes some decision what exactly to do with this customer. So this is what we will do right now. So we will turn this thing into a web service. And for that, we will use FastAPI. So I will need to install it. Pip install FastAPI, and also we'll need UVcorn. UVcorn is simply saying it's a library for running things like FastAPI, Flask, Django. So all these frameworks like FastAPI, they follow VSGI standard, and UVcorn is a tool for running these VSGI applications. If it sounds too difficult to understand, don't worry. Just in order to run FastAPI application, we need to have UVcorn. So that's the simple explanation. Okay, and now before we actually turn this into a proper web application, I want to create a simple web application. So this simple web application will, I'll call it ping. So what we will do is we'll send a request to ping, and it will reply with ponk. So let's say we have a function called ping, right? And then we just do return ponk, right? So this is a simple function. And right now, let's say we want to turn this function into a web service. Now for that, we will use, so in the course, where is it? In the course, we used Flask for that. So this is the module number, the unit number 3. So the code in Flask looks like that. So right now, what we'll do is we will turn this code into FastAPI, right? And this is how it looks like. So what we will need to do is first we will need to define an application. So we say, okay, this is a FastAPI application with the name ping. Of course, we need to have an import. So we import from FastAPI this thing. We say, okay, this is our application. So now we say that this function is actually not just a function. This is an endpoint, meaning that you can access this function using a URL, right? And then you do it like that. So you say, this is the URL that you use to access this function. It's called /ping. And when you set a GET request to this URL, you will get the response. If you don't know what is the difference between GET, POST, you can check the model. You can also ask ChatGPT. ChatGPT will probably explain it way better than what I'm doing in the model. But a GET request in simple terms is when I use the browser to access this page, I'm sending a GET request to this page, right? And I get back HTML, and I see this. What we will do, instead of returning HTML, we will just return ponk. Right, and then there is a bit of extra code we need to actually run this application. So again, as I said, we use vunicorn to say that we want to run this application, and we want to run it on localhost, and we want to run it on port 9696. I need to import. How do I actually do this? Yeah, like that. Okay, so this is the simplest web service. Think. So now we have this web service. It's running, and I will open a new terminal, and I will send a GET request to localhost 9696/ping, and I get back ponk. And my Visual Studio Code detected that there is a new application running on this port. So actually, I can open it in the browser, localhost 9696 ping. I already, because I already experimented. So if I just do this, I'll say, so yeah, I don't know what you're talking about, but if I do ping, I get back ponk. Right? So there is a question, isn't port 8080 standard? It might be, but yeah, because previously I used this port 9696. That's why I used the same port. 9090 might be standard, so go for it. I don't remember. Let me actually check if we don't specify the port. Can I see it? Okay, I think I have something wrong with my Python interpreter. It doesn't show any suggestions, but probably like if you omit this port, if you don't include it here, probably it will run on 8080 or just 80. I don't know. But we can run it on any port. And one nice thing about, so this what I just did is exactly the same. If you do it in Flask, you will have the same result. But what is nice about FastAPI is it has this very nice URL /docs that describes all the endpoint, all the functions we have in our application. So in particular, we have just one. So it's called ping, and we can see the description of this function. What is more, we can even try it here. Try it out, execute. It is executed, and it says this is the response, right? And even it gives us the get command that I can, this is wrong. I can execute. So for example, if I want to execute it, so this is the kind of the same as I did here, except it added a few other things, right? So this is really convenient, and we will see later that this is really useful. But so far, we just created this Python application that responds to ping with ponk. Not super useful, but at least something we can start working with, right? So now let's take a look, another look at this thing. So here, instead of sending the customer, I will just copy it to a new window. Instead of sending the customer, now we want to get the customer through a request. So let's create a function called predict. It will take in a customer, and then it will make a prediction, and then it will respond with churn. This will be this thing, and churn probability. How did I actually call it here? Yeah, so I have a function which I call predict single, and then there's a function called predict. I think here I am not correct. It should be 1. Because 0 would be, so what it means here, take the prediction for the customer line 0, and we have only one customer, so that's why it's always only one thingy there, so 0. And then the first thing here, 0, it would be probability of non-churning, and this would be a probability of churning, right? Okay, and now in predict, so what we do is we take, we use this function, customer, And then we return churn probability and churn. I will just copy paste it. So we'll have two things. The probability, if we ever need it, and binary prediction, whether we think the customer is churning or not. And this piece of logic, I will move to, let's say it's our marketing department. So what they will do is they will somehow invoke this function, and we will finish this later. Like we did here in pink, so we will need to do this thing again. It's predict. Let me import it. So we have unicorn, FastAPI. So this will be, how do we call it? Churn prediction. And this is actually where we want to put it. And it should be post. And here, let's say the endpoint, the name of the URL will be /predict. So we create an application, we load our model, we have the function for making predictions. It's in our case super simple, but it might become more complex. And then there is this function, right? And we also need this part. Okay. I don't know if I just run it, if it will work or not. So let me test it. So I will stop this thing. Predict. It seems to work. I know it will not. But let me try to open the documents. So again, the URL is this doc. We have this endpoint, predict. But then customers, actually what we want to put here is a JSON. But yeah, we cannot do this. So I cannot even, can I try it? So, yeah, I think, let me try to, did I remove it? Pity. So I'll take the customer that we created earlier. So this one. And I will quickly ask ChatGPT to turn this into JSON. Turn this into JSON. Because this is a Python object. In JSON, we have double quotes, not single quotes. Okay. So I will put it here. I don't know if it will work. Yeah, it doesn't. Because we actually need to send JSON and not a usual post request. And right now, FastAPI doesn't know what we want from it. So let me put it here. Actually, I have it here, but yeah, not needed anymore. So we need to say, to tell FastAPI that we expect a dictionary here. And to do that, we need to add a type hint and an annotation here. I don't remember it by heart, but I have it here. So we say that it's a dictionary. So we say that this customer is a dictionary. The key is string, which is usual, and the value could be whatever, right? And I think that's the only thing we need to change, actually. Right, so now let me refresh this. Yeah, I did not. There is also just a second. There is also a way to reload it. So right now I need to run this Python predict when every time I change the code, I need to stop the server, run the server again. This is not convenient. There is actually a function to watch the changes. So this is how we do. We again can use unicorn for that. And wait. So, and here we need to say the app we want to execute. It's predict. because it's predict.py. And inside predict, we have up. So it's predict : up. And then we have this -- reload thing. So right now it says we'll watch for changes in these directories. So every time we change this file, it will automatically detect the changes and we will not need to stop and start the server. Okay. So what do we have here? Let me update it. So now I want to try it out. So I say try it out. So this is how I ended here. So I clicked here first, then try it out. And then here we can put some value. So the value that we have, this is the value. So I can put it here. I can click execute and I get back an internal server error. Okay, so let's see what is the error. So I did not expect any errors, but apparently it is. And this stack trace is so long, I have no idea what the problem is. Yeah, it says name prop is not defined. So probably because I was copy pasting, I did not. So let's see. Yeah, it automatically reloaded. I don't think I will need to really execute. Oops. Where is my customer? Cool. Works this time. And conveniently, it gave us this curl command. So what I can do is copy it. And instead of using it from the browser, I can do it from the command line. And we see that we have a prediction. So right now, remember we created this marketing.py. So now let's actually make use of it. For that, we will need to have a library, install requests. So this is the library that we can use for sending and receiving requests. Import request. And our URL is localhost, it's HTTP, localhost 9696/predict. And we send the request. It's actually response requests dot post. Our customer is here, right? Customer. Then URL. We say JSON customer. So we send JSON and response.json. So now we get some response. We parse it and we call it churn, for example. And if churn, what is it? Churn. I think it's like that. Let me quickly just test it. Python test marketing. Yeah, so this is the, let me call it differently, response. So this is the response we received. Churn probability is this one. The decision churn true. So send email with promo. So right now, this is the marketing department. Now they can implement actually some logic here, right? And they can loop through all the customers like that, and for each of them get a decision whether to send an email to them or not. Of course, this is a simplified. It's a little simplified, but yeah, this is how, more or less, of course, with some extra things, this is how it can look like in practice. Right. So what we have already, we have this predict service that is running. It's accepting some customers, and we have this marketing department that can send a request to the prediction service and get back the response and decide what to do with the decision of the model. This is exactly what we can do. I see there is a comment. There are two variables in the predict function. Okay, I think I fixed it. Anyways, I'll close this one. Yeah. So right now we have this, and what we did here in the deployment module is very similar. So serving the churn model with Flask. So the code we wrote was very similar to that, right? What we want to do now is actually, because FastAPI is more powerful than Flask. And right now we just kind of repeated Flask, but we can do other things on top of what we have. And Flask is quite good when it comes to validating requests. So we can define the schema. So let's say right now, if I somehow change something here. So for example, instead of senior citizen 0, this thing can actually only accept zeros and ones. But what if I send 10? The model still replies with something. Weirdly, the churn probability becomes super large, right? So this is invalid input. But our model, instead of saying, hey, something is wrong, it simply processes this request. And if there is a mistake on the marketing department side, then yeah, we cannot catch it. And actually, this is the answer to a question that I see in the live chat. What is the advantages of using FastAPI versus Flask? So this is one of the advantages. So there is a very strong built-in mechanism for validation, and we can make use of it. So for that, we can define a class. So this actually uses Pydantic. Pydantic is, Pydantic. Pydantic is the data validation library for Python. So this is how we use it, and we don't need to install it because FastAPI comes with Pydantic. So I will go to predict.py. I will add this import base model, and now we will need to define two things. We'll define the request and we'll define the response, right? So when it comes to request, we can call it. Let me just quickly see how I called it in the workshop. I called it customer. Okay. So it's a class customer, and it extends the base model. And now we can define what are actually the fields for this customer, right? And the fields are, if we look at, the fields are gender, senior citizen, partner, dependents, and so on. So for example, right now I can add a new field, which is whatever, and value is, I don't know, like that, right? So now if I execute it, I don't know, will it break? Will it work? Yeah, well, something, I think we managed to break it. But we managed to break it because of a different reason. Okay. Yeah, it kind of still works. So you see, wait, just a second. Okay. It still works, even though we added a new thing, it still works. Right, so this is not how it should be. So here in the customer, we can define all the values that it's supposed to have. And if there is a value missing, or if there is an extra value, it will tell us, hey, something is wrong. So there is a comment from Vitaly that you can also use Pydantic to validate requests with FastAPI. Yeah, you can do this. It's just FastAPI becomes kind of the standard, and everyone was asking me to update the materials on FastAPI versus Slack, so this is what I'm doing here. But in principle, I think at the end, the underlying principles are all the same for Flask, for FastAPI, but now you will also know how to do it with FastAPI. Okay. What I really like about FastAPI, maybe Vitaly will tell me now that it's also possible. What I really like is this /docs, because it exposes all the endpoints in all the OpenAPI format, and then it has this nice Swagger visualization. Probably you can do something like that with Flask too, but here it's out of the box. Anyways, where did I stop? So we were talking about adding Pydantic. So I will again ask ChatGPT. So create a Pydantic class for this request. Here we also need to know what kind of values can accept it. So there are many. So for example, font service could be yes, no, but here multiple lines, no font service. So I don't really remember what kind of values could be here. So let's see. So we have this data frame. What I want to do is to iterate for all the categorical values and do data frame. So when I do data frame, let's say gender, and do value counts, I get this nice statistics. So I want to do it for all the categories I have here and print. And also do the same for numerical. Not exactly the same. So for numerical, I want to do total charges describe. So then it gives some other information like what is the minimum and so on. Sorry. Okay. So here I will do describe. Okay, and the next thing I'll do is I'll just copy all that and put to ChatGPT, say, here's more info about the data. Yeah, so now it gives us the model that we will need to use. I don't know what is it's constraint integer, constraint float. We don't need constraint, I guess. Well, it should be greater than 0 in all cases, right? So probably constraint is okay. So what I'm going to do is just simply copy it. Of course, you can do this manually. So because you see all these values here, right? So you can say, okay, gender is male and female. So then you go here, gender, literal, male, female. But I'm a lazy person. That's why I just asked ChatGPT to do this for me. Okay, so this is our customer. I will also need these imports. And here we'll only have greater than, so it will be greater than 0. I don't know, actually I never use this conint or confoot. Let's see if just greater in is enough to have. And then there is a response. For response we have two things. We have churn probability and churn. Instead of asking ChatGPT, I will simply copy it from here. And actually, previously, it created something slightly different. So you see it uses this field, not con thing. But anyways. Okay, and now instead of customer dictionary, we say customer. It's a customer, and the response is, what do we call it? Predict response. And now it gives us a customer, and we turn this customer into a dictionary, because this is what our model expects. And output predict response, right? Which is churn probability, this one, and churn, this one. Okay. So let me try to run it. Why does it still work? Okay. Yeah, well, it was not supposed to work, but right now, let's just pretend you didn't see this. Because I want to make sure I cover all the material I prepared, so I will not spend now time. Maybe let's try to make this mistake. So what happened? Unprocessable entity. Okay. Well, I think so we need to change it slightly to also deal with the cases when, yeah, this unprocessable. Anyways, so right now let's focus on the happy path and we will come back to this. Right now, the happy path is working. So I will comment this one. So this is 0. Okay. So it works. And we added this definition for the customers. Okay. So now I see that there is a question about UV, which is about time, because this is something we want to cover right now. So we took, so what we did so far is we took this model that we trained here in this Jupyter Notebook. We then converted this notebook into a script, into two scripts, train and predict. Then we turned the predict into a web service. And now imagine we have multiple services running on our computer. So let's say my colleague is on vacation and they asked me to fix something in their code, right? And instead of using scikit-learn 1.7, they use scikit-learn 1.1, which might be not compatible. So for this situation, we want to have each project running in an isolated environment. So my project has this version of scikit-learn, their project has a different version of scikit-learn, and they don't conflict with each other, and they can live in one on one computer. For that, we use virtual environments. We use different dependency management tools, and one of them is UV. So there are actually multiple. So you can just use plain virtual environment. It's called venv, right? This is a little inconvenient because you need to use this txt file. Well, I will not try to spell it correctly right now. Now you will need to always manually change it. It's a little inconvenient. Then there are tools that help with that. It's called, one is called pipenv, another is called Poetry. So these are very nice tools, and I really like pipenv. But the problem with them is they're slow. They're written in Python. But there is another tool which is quite recent compared to other tools, which is very similar to pipenv, which is very similar to Poetry, but it's written in Rust, and it's way faster. It's a lot faster. So when I switched on some of the projects we have here in DataTalks.Club, one of them is actually this. This one. Right, so this is written in Django, and it used to use pipenv as the dependency management tool. Now it uses UV. I think it saved like 1 minute per each build, if not more, because pipenv takes time to download the libraries to solve the dependencies. UV is very fast. So we will install it now. Pip install UV. Now let me stop this thing. And next I do UV install, UV init. So now I create an empty UV project. We see that there is a new file, Python version, and there is also PyProject.tom, right? So this is a description of our application. So now we can add our description here, churn prediction service. Okay, and now we can add UV, use UV to install dependencies. So in our case, we have scikit-learn. We have, what do we have? FastAPI. We have pandas. Oh, well, pandas is for training. So this we can, for now, just not think about this. So this train.py can be a separate project from serving. So one project is for training the model, the other project is for serving. Right now, let's focus on the serving one. FastAPI, and we also need UV corn, right? So did you see how fast it was? Right? So it was really cool. So it installed scikit-learn, FastAPI, UV corn. And what we have now, if we go to where's this? It added dependencies, and it also added this uv.log file. So here it describes all the packages. So scikit-learn depends on NumPy, right? And we can see that here we also have information about NumPy, right? And also it says which parts it downloaded, what are the hashes for this. So when so the reason we want to have hashes here is what if something happens with our internet connection? We download a damaged library, then the hashes mismatch, and our build will fail instead of failing in production. So that's one of the use case. Or maybe somebody replaced the package on this URL, and maybe there is some malicious code there. So then you will be able to detect it. Okay, so we have this, and then we also have a development dependency, because for running this thing, so let's say we want to run it for testing, right? We need to use requests. So I will do uv add /dev or --dev requests. And what happened now? It added a list of dev dependencies. So dependencies we only need for development, but we don't need for production. You see also it created this .venv folder that contains all these libraries. So we see Pydantic, we see request, we see scipy, scikit-learn, like all the stuff. So all the dependencies, they live in this venv folder, and it's different for each project, right? So if I get a project from my colleague, then this venv directory will contain different versions. And in order to run something in this virtual environment that we just created, we need to append to write first uv run, and then whatever we want. So uv run this one, and here when we write, oops. So here uv run Python marketing. Right, so both of these things will run in this virtual environment. So let me see if we have questions. Do we have access to this notebook and to the code of this session? Yes, this is here in the workshop. It is in the description here. So this workshop, you just click on this link and you will see all the code. Okay, so we did this, and I showed you how to run it with UV. And now it's time to put everything in Docker. So the case, we talked about the use case of using UV. And this is to isolate different things that run on our computer. Sometimes we have what we call system dependencies. So let's say our library depends on, so there is a thing called LAPACK. So this is something that NumPy uses for linear algebra. I think it's called linear algebra pack. And let's say one project requires one specific version, a different one requires a different one. Or maybe they need a different version of Linux or different version, I don't know what. So they have not just different Python versions, not different, maybe Python versions are another good example. But sometimes there is more that is different, not just Python libraries, but there are some system libraries. So then running them on one computer becomes difficult. Or this is something we'll also talk about when it comes to deployment. We want to take our program, our web service, and make it self-contained. Everything it needs, including system libraries, including Python libraries. We want everything to be in one place. And then we can simply take this container, quote unquote, and deploy it to the cloud, and then it will just run. If it runs on our computer, it will also run in the cloud. Again, I'm not sure if what I described makes sense to you. If you don't know Docker, if you know Docker, then yeah, it definitely makes sense to you. What I will say is I will not spend a lot of time describing it. I will again refer to our course, where we talk about Docker, we talk about different use cases, why you need Docker. And here in this environment, I already have Docker installed. So if I do Docker run hello world, it will just run. And yeah, it works. For that, I need to create a Docker file. So this is a file that describes everything we need to, everything it needs to do to prepare the application for running. All the files, all the system libraries, all the dependencies, everything has to be in the container. And we do it by describing the things we need to do in the Docker file, right? And then Docker will execute things one by one from this Docker file. So is UV similar to Docker? So they're kind of, let's say, different levels. So UV is only for the use case is you have one computer, multiple projects. But use case for Docker is you want your project to be self-contained, contain only things it needs, and do not contain other things, such that you can easily take this container and put it somewhere on the cloud, or make it completely reproducible. So whatever we here put in the Docker file, I execute, you execute, we will have the same results. Right, and usually the first thing we have in the Docker file, it starts with from statement, and we want to use the we want to take the basic Python image and base our code on top of that. So the version of Python I have here is 3.12.1. So I'm going to write from Python 3.12.1. So, and this way, it will get a package. It will get a container. It will base our image on the image of with this tag with this version of Python, right? Then the next thing we want to have here is we want to make sure we have UV. So what we typically do is pip install UV. It will work. I will do it like now, like this now. We will see a different way later. And the next thing, we need to install the libraries. For that, we will need to copy. What do we need to copy? PyProject Toml. We will need to copy Python version. PyProject Toml and uv.log, and we copy it to the current directory. And by the way, I did not specify what the current directory is. Work there is, let's say it's app. Right, so it's the same as doing cd app, but inside Docker. And now when I execute this command, copy, it will actually copy this, and this to the current directory, which is in our case app. Right? The next thing we need to do is we want to run UV sync. So we run UV sync is, let's say, when I get a project from my colleague, instead of doing the way we did is UV at scikit-learn, UV at pandas, whatever, it can just go to uv.log, see what kind of libraries it needs to install, and install them. And if we do UV sync, so what's the flag? I don't remember. Let me check. So this is how we do this, UV sync locked. So it actually, oops. It makes sure to use these exact libraries that are specified in this uv.log file. So once we install all the libraries we need to copy our predict.py. So this is the code with our web service. Of course, in practice, we typically have more files than we can specify all of them, or they are often in a folder. So then we simply just copy a folder. So we need to copy predict and model. So again, we copy it to the current directory. And then what else do we need to do? We need to expose the port. So because we run, where it is? So we run on this port. So we need to tell Docker that, hey, we will try to run something on this port. So make sure this port is available. And then the final thing we need to do is this entry point. Right? Entry point says what kind of thing it needs to execute. So when we do Docker run, what exactly will be executed? And this is the same thing as we run here. So let me stop it. So we did this, right? Except here we have reload. But in this case, we don't have reload because the files are not going to change, right? So that's why we don't add reload here. But otherwise, it's the same command. We do not want to prefix it with the UV run because there is only one environment inside Docker. Sorry, I thought I was muting myself. So there is only one environment inside Docker. So technically, I think let's just do this. UV run. So we will take a look at the simplest case. So pip install UV, work dir. So let's see if it works. So I will do Docker build. And then I need to specify the tag. I'll call it churn prediction. And then dot. Dot means current directory. So it cannot find predict. Let me see the syntax. Maybe. Yeah, I don't use commas here. Let's see if without commas it will work. So it's doing something. So right now, what it's doing is downloading the version of the Docker image with Python. Yeah, it takes a bit of time. It's a fairly large image. And then it will execute all the commands we have here, line by line. So it will first install, it was fast, right? So it installed this one, then created a directory. Okay, it just worked. Well, we don't know if it works or not, but it finished. So let me copy this command to file. And now we will need to do Docker run. Then -at means, so Docker run means we want to run a container. -at, we want to run it in interactive mode, which means if I do Control-C, I can stop the container. Then -rm means after I stop the container, I want to remove it from the system. Then I need to do port mapping. So I want to expose, so we expose port 9696 on the container. I want to map it on the port 9696 on my computer. And then this is the image that we want to run. So let's see if it will actually work. Okay, it seems to work. We get a warning because I don't know, for some reasons we get different versions of scikit-learn in Docker and outside. Weird. I don't know how it happened. It was not supposed to happen. Probably I need to re-execute this train.py with the same version of scikit-learn as we have here in the virtual environment. Anyways, for now, let's ignore it. We see that this is running. We see the port. So what I will do now is go to this port. Of course, it's not Spring, it's docs, and try to send something. Execute. And you notice that because we have schema, right now it came up with like a basic example. And we can see that actually it works. It works inside Docker. That's cool. I wanted to simplify it a little. So first of all, this image is pretty large. Maybe you remember that it took a bit of time to actually run it. So there is a lighter image that we can use, which is called this slim bookworm. Slim means that it's slim, takes less space. Bookworm is a distribution of Debian. So that's the first thing. And then instead of installing UV like that, we can copy these binaries UV and UVX, which I needed. I don't know if we actually need UVX, but this is the recommended way of doing it from the UV team. So if you go to UV documentation about running it in Docker, they say, okay, you install it like that. So instead of doing pip install, it will create fewer temporary files this way. So it should be faster. So let me just try with these two changes to see if it still works. So I think it was a little faster downloading the base image. Okay, and when I do run, it seems to work. Okay, so now what I'll do now is I will again go here to docs to verify that it's working. Yeah, it's still working. Cool. And one last thing I want to change here is instead of doing UV run, I just want to do this UV corn predict. So everything, no matter what we run here, it will always run inside the virtual environment, even if we don't write UV run. And we can do this by modifying our path variable. So here. So because we know that our venv virtual environment lives here in this directory. So we can do this. We can say everything that lives inside code venv is globally available. So then we don't need to always prepend UV run. So let me execute this. And again, this is the recommended way of doing it from the UV team. Okay, so did I, maybe I need to put it here. Yeah, it doesn't seem to. Yeah, of course, because it should be up, not code. And now run this. And it, because we added this to path, if you don't know what it means, you can ask ChatGPT. We added this to path, and right now we don't need to prepend with UV run. Okay, so this is the final version of our Docker image. So it works. Now it's containerized, and I want to quickly show you how to deploy this. I think it will not take much time, maybe 5 minutes. So in the course, we use Elastic Beanstalk, which is a convenient tool, but it's also a little outdated. So there are simpler ways of doing this. And when I was doing a bit of research to see what I can show you here in this module, in this workshop, I came across fly.io. Actually, ChatGPT suggested this, and it's super simple. So I want to show you. I don't have a lot of experience using this tool, so it's up to you to see to learn more about this or select a different tool. but from what I saw, it's super easy to use and install. So it's just these few lines of code. So I will now install it. Okay, so it says to do this, manually add the directory. So I will do nano bash rc. And let me make it larger. I will just add it here. Okay, and when I execute it, when I will create new terminal, I probably made a mistake when running it. Yeah, there is a quote. Okay. I will close it and create a new one. Now, when I do which fly, yeah, it points to the right binary that we just downloaded. Okay, now I need to authenticate. For that, you need to create an account. Actually, like, to be honest, I don't know what is the pricing for fly.io. I know that you can deploy a few things for free, but then at some point they also want to earn money, right? So I don't know what's exactly their model. So it's up to you to check the pricing. Okay, what else do we need? Then we need to execute that, launch. Okay, do I want to tweak the settings? No, I don't. Create Dockerfile. Yeah, create. Docker ignore. So it created Docker ignore. And right now it is deploying. So this is actually the last step. So right now we will wait a little. As we are waiting, it's you see it's doing some things. So it will deploy our application to the cloud. And once it's done, we have a URL. We will have a URL that we can use for accessing our service with this URL. Okay, something's happening. So it says, yeah, so it's going to. So this is the name of our deployment, lingering wildflower 261. Okay, and we can open this in the browser. What? Oh, okay, yeah. Yeah, it's doing something. Okay, and now our application is deployed here. I will open it. And for example, I can go to docs. And this is the docs we saw previously. So I can try it out. Or is execute? I can execute it, and this is the response. What we can do now is I will take this URL and we go to our marketing.py. And here we will replace the URL we had previously with the new URL. And I will do Python marketing. And what happened right now is we locally send a request from this marketing.py file. We locally send a request to this URL that we deployed with fly.io to /predict, and it replied with the decision that we need to send an email with promo. So that's pretty much it. The only last thing we need to do is let's disable our apps, the thing we just deployed, so we don't accidentally get any charges. Because again, I said, this is the first time, or maybe second time I'm using this tool. I really like how simple it is. So that's why I wanted to show you here. But also there could be some hidden things that I'm not aware of. So please check it out to see like what's the pricing model there. So right now what I want to do is to call this destroy, or first apps list, to see the things we have. So this is what I just deployed, lingering with flower. So I'm going to do call destroy and the name of this app. Yes, destroy. Okay, and now the app should not be available anymore. Okay, so this was fairly simple. So what we did here in this workshop, so right now this is the end of this workshop. So what we did in this workshop, we started with this notebook. We went through, we had a model. Then we converted, so we had two steps, dictionary DictVectorizer and logistic regression. So then we used pipeline to make it easier. We saved it with pickle. And then finally we exported this notebook in a script, and we split the script into two parts. First part is train.py. Right? So this is the thing that trains the pipeline and saves it to a file. Then we had predict. So predict used to look a little different, but then what we did with time is, so here we started, remember, we started only with this line, right? But what we did over the course of this workshop is we turned this into a FastAPI application that takes in a customer and returns this predict response. And this application could be used by our marketing department to make decisions on whether to send an email promotion or not. Then we talked about virtual environment. We talked about EUV as a very convenient tool for managing virtual environments, for installing dependencies. You saw how fast it is to actually add dependencies. And then so with UV, we could isolate environments between different projects, but with Docker, we can take it one step further and have a completely isolated environment for running our application with the specific version of Linux, with the specific version of Python, whatever we need, right? And then we defined everything we needed here in the Dockerfile, right? And then when we do Docker build, it executes all the steps one by one. And when we do Docker run, it executes this command. So this is what we did. We got an application that we can run inside a Docker container. And once it was inside a Docker container, it was fairly simple to deploy it to the cloud. In our case, we used fly.io. But because it's containerized, we can actually deploy it anywhere we want it. So for example, we could have deployed it to Elastic Beanstalk. This is what I show in the lessons. It takes a little longer, but the number of commands you need to execute is fairly similar. Or you can, here, I think I list different options. So Google Cloud Run, AWS App Runner. Also in the course, a lot of because we run the course for so many years, students explore different options, and yeah, so there are different options for deploying your applications. You can check it out. But I really liked Fly.io. It's super simple, just these 3 commands, and you have your application deployed. Okay, so that was it. If you liked this, you can learn more about machine learning engineering. So the link here to the course, we have this course and module number 5. So the sign up button to the course, you can find it here. If you want to sign up for the course, we start in September, and we'll go over all these modules together. Yeah, that's the plan. And actually, when we do the course for the deployment model, I plan to use the content I just presented as an update to this module. So here it will be one more point, one more unit saying, hey, here's an update. And I'm going to use this session that we had today there. Perhaps maybe I still need to figure out, I don't have time right now because it took more time, how to do proper validation with FastAPI. Perhaps I'll record a short follow-up video. But yeah, that's it for today. Apologies, I was a little sick. That's why I was coughing a little. But yeah, I didn't want to cancel this workshop because it's also a little difficult for me to find a different time slot for this workshop. So apologies for that. I hope I didn't cause any inconvenience. I remember I accidentally forgot to mute when I was coughing. Well, anyways, thanks everyone for attending, and sign up for the course if you want to learn more about this kind of stuff, and see you around. We actually have a lot of workshops planned, so be sure to subscribe to our channel. Don't forget to like this video. What else? Yeah, go to DataTalks.Club. Maybe this is something I can show you. Here in the upcoming event session, you can see what kind of things we have. So this is today, this is tomorrow, and yeah, that's it for now. And I will not turn on the video, but yeah, it was fun doing this. I hope you enjoyed it, and yeah, well, see you soon. Bye, everyone. So now I'll need to figure out how do I stop